Hi everyone, I'm Lakshmi Indira Kuppa, and this is my Teach One for HAP823, that is Causal Networks and Comparative Effectiveness. This course is taught by Dr. Farooq Elimi and Dr. Ronald Wooderman. My Teach One's topic is related to linear regression. It is a statistical method that models relationship between two variables, that is independent and dependent variables, by fitting a linear equation to the given data. One variable, that is independent variable, is also considered to be an explanatory variable, and the other is considered a dependent variable. Linear regression helps in modeling relationships between independent and dependent variables, allowing us to predict outcomes and understand the significance of different factors in the model. Especially in healthcare, understanding the impact of interventions on patient outcomes is very important. Likewise, electronic health records provide a rich source of data that can be used to make these assessments. Coming to the question 3 of regression networks, week 6, we'll go through the question first. That is, inside an electronic record, there are data on outcomes of a particular intervention. Using the network drawn below, write the equations that would allow you to estimate what would happen if the intervention was not given. First, write an equation for each node in the network based on that variables that precede it and indicate the significant relations with an asterisk. Coming to the basic linear regression equation, this is the basic regression equation where y is the response variable or the variable that we are trying to predict. Alpha is the overall constant or the y-intercept. It represents the baseline level of the response variable. Beta, that is the regression coefficient. It is also the slope. X is the explanatory variable. It is the independent variable or the predictors in the model. And the equation ends with an error term, that is E, which is also a random error or noise in the model. It is also the unexplained variance in the model. Coming to the first part of the question, that is, we write the equation, the linear regression equation for each node in this network. Firstly, we go through the severity of illness. It is the root node, as we can see. It does not have parents. We labeled it as beta 1. Here, the severity of illness beta 1 will be equal to alpha 1, that is the y-intercept itself. Coming to the provider's decision, that is, we labeled it as beta 2. It is also a root node where it has no parents in the given network. It is also equal to alpha 2, its overall constant, that is y-intercept. Coming to the do not treat preference in the network, we labeled it as beta 3. And do not treat preference, as we can see through the network, it has a parent of severity of illness. And the equation goes like this. It is alpha 3, its overall constant, plus beta 1, and severity, the value of severity can be varying, and we do not know the value as per the given question. Hence, we just write it as severity and an asterisk. Coming to the intervention and treatment, we label it as beta 4. And here, as we can see through the network, it has three parents, that is severity of illness, do not treat preference, and provider's decision. And the linear equation goes like this, where alpha 4 plus beta 1 severity, that is its explanatory variance, plus beta 2, that is provider's decision, and beta 3, that is do not treat preference. All these are added. Coming to the adverse outcomes, that is Y, we labeled it as Y. It is the overall outcome. That is, the linear equation goes like this as per the given network. It has three parents, that is severity of illness, intervention treatment, and random chance. Hence, we write it as alpha plus beta 1 severity, beta 4 treatment or intervention, plus E or random chance. These are the equations we have written for each node in the network. Now coming to the main part of the question, that is estimate what would happen when the intervention or treatment was not given. When this is not there, then all variables, some things are to be noted. That is, all variables are binary except for random chance because it can be any value. And occasionally the severity of illness cannot be a binary because severity can be described into multiple categories such as not severe, mild, moderate, and severe, as I have given here. These are the things that we have to be noted before proceeding further. And coming to when intervention or treatment is zero, there are two instances that can happen. That is, first, outcome mainly due to the random error, as we can see through the network. The adverse outcomes, that is Y, is alpha plus beta 1 severity plus beta 4 treatment plus random chance or E. And here, only we label only E and we assume severity and treatment to be zero. Then Y, that is our adverse outcomes, will be alpha plus random chance. This is the first instance. Coming to the second instance, that is outcome due to severity and chance. Here, adverse outcomes Y will be alpha plus beta 1 severity, beta 4 treatment plus chance, as we can see through the network. Here, we assume severity not to be zero. That is, it can have multiple categories as we have discussed before. Here, when we assume X or the explanatory variable to be a value, a certain value that is not given right now in the question, then the equation goes like this, where Y equal to alpha plus beta 1 X, a given value, plus random chance. And here, as per the question, treatment or intervention has to be zero. Hence, beta 4 into 0. Hence, this is the last equation. These are the two instances that come when intervention or treatment is taken as zero. This is my teach one. And if you have any questions, you can reach out to me. Thank you.